My turn. Given that g is directly proportional to t squared, and we know when g is 450, t is 7.5, we need to complete the table. So the initial element of this is exactly the same as the last couple of lessons, because it's the application of direct and indirect proportions. So we know this is going to actually be g equals k t squared, where k is my constant. I know two values, so I can find k. I know I've got 450 is equal to k times 7.5 squared. This is going to give me 450 is equal to 56.25k, which is going to give me k is equal to 8 when I divide through. Now I substitute that in, so I now know g is equal to 8t squared. I'm then going to use that equation to find the two missing values. So let's call this one a, I'm starting with g equals 8t squared. I don't know g, but I know t, so I get 8 times 2.5 squared. That is going to give me g is equal to 50. Let's call this one b. I know my value of g this time. I'm going to go straight for plugging that in. Is equal to 8t squared. That means I'm going to get 100 when I divide through by 8 equals t squared. The square root of t now, square root through. If you've got a squared and you need the value itself, you square root through. I'll get t is equal, the square root of 100 is 10. Pause the video here, take a look at what I've done, and have a go at the your turn question. So, your turn. We know that when a ball is dropped, the distance it drops, d, is directly proportional to the square of its time, t squared. That means we're starting again with d equals k t squared this time. I know from my table that when d is 4.9, t is actually 1, so I get k is 1 squared. 1 squared is just 1, so 4.9 is equal to k. I substitute that in, I now know d is equal to 4.9 t squared. I'm then going to find my two missing values. Again, I'm going to label them a and b to help us keep track. So for a, I'm missing my d value, so I'm going to get d is equal to 4.9, t being 2 this time, 2 squared. That is going to give me, when worked fully, 19.6. Just multiplying. 2 squared is 4, so I end up with 4 times 4.9, which gives me my 19.6. For the next one, I know my d value this time, so I get 28.2 is equal to 4.9 t squared. I start by dividing by 4.9, which will give me a long decimal answer. So I actually end up with 5.755, etc. is equal to t squared. I'm not going to round just yet because I want to make sure I get to the correct final answer. So what I'm going to do is I'm going to leave that in my calculator, and I'm going to use that then on the next step, rather than round it now and maybe have a little bit of a problem on the next step. So now I square root through, because again, I've got a squared value, I need just the value itself. So once I square root, I end up with a long decimal again, but when I round it to 2 decimal places, I end up with 2.40, and that's to 2 dp. I round now because I want a rational answer to put in my table. We don't round early on because that's where earlier errors can enter our calculations, so try and avoid it if you can. It's easier to round a little bit earlier. Just make sure that you are checking your answer fully before you put it in. So my final answer here is 2.4 or 2.40 to 2 decimal places. Take a look at these two questions and have a go at the next slide.